Hello everyone, welcome back to Let's Do Mathematics. Today we are going to solve a very interesting integral problem that involves the greatest integer function and least integer function. Now we have given integral is integral from 0 to 20, least integer function and greatest integer function x over 2 dx. So first of all we know that for every x in k to k plus 1, where k is integer, an integer, greatest integer function x is equals to k. And also we know that, and for least integer function, so this is for least integer function x, this is the definition, is that the largest, the smallest integer that is greater than x. So this is the definition of least integer function and greatest integer function. Now using this definition we are going to find out the solution of the above problem. So first of all, if we have, so we know that for any interval, for any integer k in x, if x belongs to this interval k to k plus 1, the value of this greatest integer function is k. So we can write this integral in the form of summation. So the function is constant over each interval of length 1, therefore the integral reduces to this sum. So we can write this integral as 0 to 20 least integer function, greatest integer function of x over 2 dx is equals to summation k is equals to 0 to 19. This is integral from k to k plus 1, and this is the value of this is k over 2 dx. As we have seen here, greatest integer function is equals to k. Now we can write this. So we can write this integral again. We can write this integral as, so for any integer, if k is, so we must know that if k is odd, that is k is equals to 2n minus 1, then this least integer function k over 2 is equals to 2n minus 1 over 2, that is, this is n minus 1 over 2, and this is equals to n, and n is equals to k plus 1 over 2. And if again, if k is even, that is k is equals to 2n, then this can be k over least integer function k over 2 is equals to 2n over 2, that is n, and this is equals to n, so this is k over 2. So this is very simple, and we are going to break this integral into some of the finite integrals to find out the above integral. So first of all, let's write this integral in the form of sum. So the, for k is equals to 0, this 0 to 1, and since 0 is an even number, by this definition this is 0, the value of this function is 0. Again this is 1 to 2, since 1 is odd, and for 1 is odd, 1 plus 1 over 2, this is 1 times dx. Again similarly 2 is odd, so 2 is even, so this is 2 over 2. So this is similarly for 15, for example, for 15 to 16 in 15 is, since 15 is an odd number, so 15 plus 1 over 2 is equals to 16. 16 over this is 16 over 2 is equals to 8 dx. Again, since this is 16 to 17, 16 is even, so 16 over 2 is equals to 8, so this is 8. And 17 to 18, 17 is odd, so this is 9 times dx. And 18 to 19, this is 18 is even, so this is 9 dx. And again this is 19 to 20, this is 19 is odd, so this is 10 dx. So the value of this integral is 0. This is 1 times 2 minus 1. Similarly this is 1 times 3 minus 2, and similarly this is 8 times 16 minus 15, and this is 8 times 17 minus 16, and this is 9 times 18 minus 17, and this is 9 plus 9 times 19 minus 18, and plus this is 10 times 20 minus 19. Again, after evaluating this, we obtain here 0 plus 1 plus 1 plus 2 plus 2 plus this is 8 plus 8 plus 9 plus 9 plus 10. We have seen here that we have obtained the numbers from 1 to 10 two times in the sum, and 10 as single times. So adding this, we can write this as 2 times of 1 plus 2 plus up to 9, and this is plus 10. So this is equals to the summation of this 1 to 9 is equals to 9 into 10 over 2 plus 10. So 2 gets out to be cancelled. This is 19 plus 10, and this is equals to 100. So this is the final answer of this given problem. So that's how we solve this problem, by carefully breaking the integral into intervals and simplifying step by step. If you found this explanation helpful, don't forget to like, share, and subscribe to Let's Do Mathematics for more such interesting problems. See you in the next video. Thank you.